Okay guys, what we're going to do today is have a look at GCSE moles calculations again. We're going to do this using balanced symbol equations. So up to now, if we just very quickly refresh, we've had video 1, 2 and 3. This is video number 4. And on video 4 we're going to build upon the skills that we've already learned. Essentially we've already learned how to calculate relative atomic mass, relative molecular or relative formula mass, and we've learned how to convert those values into moles. We've also learned how to do empirical formula and molecular formula, but that's not so applicable in this topic. So the whole point of this little section is to really tie everything together that we've done so far, and to be able to use that or those skills that we've learned to allow us to work out how much of a product we would make from a certain amount, certain number of moles, certain mass of a particular reactant. Now the first thing we need to do is understand very carefully exactly what a chemical equation tells us. And a chemical equation basically gives us a ratio of moles, and that's important, moles of reactants to products. Now if we look at the equation here, this is often called the coefficient of the equation, but I just refer to it as the ratio. So if we look here, we will see that we have a ratio of 1 mole of hydrochloric acid, 1 mole of sodium hydroxide, 1 mole of sodium chloride, and 1 mole of water will be produced in that. Now, if that is the case, so that molar ratio is really important that you understand that. So what we're saying is that when I have 1 mole of that hydrochloric acid, it needs to react exactly with 1 mole of sodium hydroxide. That will give me exactly 1 mole of sodium chloride and 1 mole of water. So the other way to look at it is that if I have 0.1 moles of that, I need 0.1 moles of that. I will make 0.1 moles of that, and I will also make 0.1 moles of that. Likewise, if I have 1000 moles of that, I need 1000 moles of that. I will make 1000 moles of the sodium chloride, and I'll make 1000 moles of water. So that is very important that you understand how that works in order to do that. And the reason why I say that is a lot of people make mistakes because they see if I have 1 mole of that and 1 mole of that, they automatically assume that they should form 2 moles of this. So instead of working it as a ratio, they add the moles of the two things on this side, put them together and assume that they should make that number of moles of the product. That is not the way it works. It is a ratio. Please understand that. Okay, so let's take this equation and do a worked example, and we will go from there. So we write our equation first. So the first thing you need to have when you go to do a moles calculation is you have to have a balanced symbol equation. If your equation is not balanced, obviously you cannot work out the moles coefficient or the ratio. So we will just balance it first of all. Next thing we do is we write our moles ratio just above it is where I would tell people. So this is really very simple one. The whole moles ratio here is 1 to 1 to 1 to 1. Okay. And the next thing we do is we obviously have a read of the question. So let's say the examiner says to us, calculate mass of NaCl formed from let's say 36.5 grams of HCl and an excess of sodium hydroxide. Okay, so what do we need to take from this question? Well, we need to take, first of all, that the sodium hydroxide is in excess. And if the sodium hydroxide is in excess, it has no effect on the product that's made, or how much product is made. Simple as that. So we can basically ignore the sodium hydroxide there and ignore it in the equation above. The next thing we need to do is fill in the information that the examiner has given us. So he's told us we have 36.5 grams of sodium hydrochloric acid. Okay, now if I have 36.5 grams of hydrochloric acid, how on earth do I calculate out the mass of sodium chloride that is made? Well, if we go back to our formula that we learned earlier in the videos, okay, hopefully this is familiar to you, where we have number of moles or amount of moles, we have the mass in grams, and we have the mass of 1 mole of something. Well, let's have a go at this. Well, if I work out the number of moles of this, now that is 36.5 divided by, well, HCl is in fact 36.5, so I made this really pretty simple. So that is, in other words, 1 mole of that. Now, if we take my ratio, or our ratio, and we go across, and remember that it's 1 to 1, so in other words, if I have 1 mole of this particular reactant, I will make 1 mole of the sodium chloride. Well, therefore, I do have 1 mole of that, and I will make then 1 mole of that. So in other words, I have got moles of, in this instance, sodium chloride. How do I convert that to mass, which is the value that the examiner is after? Well, I take the moles and I multiply it by the MR. So moles is 1, as calculated out indirectly from the HCl. The MR of this is 23 plus 35.5, which is 58.5. Therefore, I'm going to make from 1 mole of HCl, which is 36.5 grams of HCl, I'm going to make 58.5 grams of sodium chloride. Okay, now that's really pretty simple and pretty straightforward, and a fairly standard sort of a simple GCSE question. Let's make it a little bit more complicated, but nonetheless still not particularly taxing, I would hope, for most of you. So this time we'll just use slightly more awkward values, more awkward numbers, which is the way the examiner will work. So we will use nice round numbers that we had earlier. So let's say we have 4.2 grams of this. We have 50 grams of this. I know that that's in excess, okay? And this time we're working out what's the mass of water that we are going to produce. Well, we have to do the same again. We still need to work out moles of the HCl. So we're going to do our 4.2 over 36.5. Okay, so 4.2 divided by 36.5 gives me moles of 0.115. Again, remember, we keep it to 3 sig fig. So where do we go? Well, we are looking after our water. Remember, our ratio again is 1 to 1. Okay, so if I have 0.115 moles of hydrochloric acid, I will make 0.115 moles of water. So we go back up to our formula from above, where mass equals moles, being 0.115 multiplied by the RFM. Well, the RFM of water is indeed 18. So if we take that and we multiply it by 18. That gives us a value 2.07 grams. So, in other words, if I start off with 4.2 grams of HCl, that is equivalent to 0.15 moles of HCl, 115 moles, of HCl, which is because of the reaction product coefficient, equivalent to 0.115 moles of H2O, and that is equivalent to 2.07 grams of H2O. So that then we would mark very clearly in our exam script as the answer. Now in a GCSE exam you won't just be asked to do this as I have in one fell swoop. You would be given several little broken down steps to carry this. It will be a much more structured question than I am giving you here at the minute. So we'll do now a few more which have got some slightly less friendly ratios. Okay, so the equation we have on the screen is a reaction between sulfuric acid, potassium hydroxide to give us potassium sulphate and water. Now, what I want you to first of all do is, if we read the question, calculate the mass of potassium sulphate formed with 6.54 grams of potassium hydroxide, reacts with sulfuric acid, which I've said here is in excess. Now, you can do two things here. You can watch on as I work through this, or you can pause this video, I'll go away and have a go at this and come back and see if you got the answer correct. So I'm going to do it now. So the first thing that we do is we go through the equation again and we work out our reaction ratios, our coefficients. So this time it's 1 to 2 to 1 to 2. So that tells me if I have 1 mole of that, I need 2 moles of that to react with it, and I will make 1 mole of that and I'll make 2 moles of water. So in other words, the ratio must always be the same. So the first thing we need to do is calculate out the mass of potassium hydroxide that we're going to start off with. So again, if we just pop at the side, okay, that the number of moles is equal to mass multiplied by mR, and the number of moles of potassium hydroxide is our 6.54 grams divided by potassium, which is 39, plus our 16, plus our 1, which makes us 56. So if we do 6.54 divided by that, that means that the number of moles of potassium hydroxide is 0.117. And we just recorded the three significant figures, but I won't wipe it off my calculator. You should never really, at GCSE, have to clear anything off your calculator. So we keep that value in the calculator and we work our way through. Okay, so we then have to ask ourselves, oh, by the way, just a lot of students lose marks here because when they go to work out the RFM of this or the RMM of the anything, they automatically see this 2 here, and they work out this times this, this plus this, multiply it all by 2. Please remember that the MR is the mass of 1 mole of anything, not 2. The 2 comes into play when we do our ratios of going from the potassium hydroxide to the potassium sulphate. That is when the 2's and the 1's come into play, not here. So please do not make that mistake, which costs students marks year after year after year. Okay, so let's have a look where we are. Yes, so we've said here that for 2 moles of the ratio is 2 to 1. So when we go across here, it's 2 to 1. So our 0.117 has got to be divided by 2. Okay, that means that we will produce of potassium sulphate 0.0584. Okay, another common mistake that is made here is that people go 2 to 1 and they take this value and they multiply it by 2. Remember, there's half of this compared to the potassium hydroxide, half of it, so you must divide by 2. Alright? Now we are after mass. The examiner's asked us to calculate mass, and when we're asked to calculate mass, it is moles, which we have worked out indirectly from the potassium hydroxide, and MR multiplied by MR. So if we multiply that by the MR of potassium sulphate, so the MR of potassium sulphate is, we have 2 potassium, so we have 2 times 39. We have sulphur, which is 32, and we have 4 oxygens. Each oxygen is being 16, so we have 4 times 16, which is 64. And if we plug that in, gives us an answer of 10.2 grams to 3 SF. Okay, so hopefully this is becoming a little bit clearer for you now, and you're able to work these out. So what I will do is I will pop a few on here. As they come up, I will work through them, but if you want to pause the video yourself, and when you've paused the video, then have a go at them and then come back and check. So I'll do 2 or 3 more, and hopefully by the end of that you guys will have all got these and be able to do them. Okay, so we have the equation of iron reacting with sulphur to make iron sulphide, and we have 2 questions here, split into parts A and B each. So question A says calculate the mass of iron sulphide made from firstly 32 grams of sulphur and then secondly 10 grams of iron. We'll assume when there's 32 grams of sulphur the iron is in excess. We will assume when there's 10 grams of iron that the sulphur is in excess. So the first thing we'll do, as we always do, is go up and write the reaction ratios. So it's a nice simple 1 to 1 to 1 here. The next thing we will do is do our calculation. So we've got 32 grams of sulphur. 32, remember again, always write it at the side, guys, no matter how well you think you know it. Put it down, always to remind yourself. So number of moles of sulphur is equal to mass, which is 32, divided by the MR. Well, that's 32 divided by 32, which is obviously 1. Remember, our reactant ratio is 1 to 1. So therefore, if we have 1 mole of sulphur, we will make 1 mole of iron sulphide. So we've got 1 mole of that. And remember, mass is equal to moles multiplied by MR. Moles are 1. MR is 56 plus 32, which is of course 88. So the answer is very simply 88 grams. Okay, the second part then is we have 10 grams of iron. We're assuming that the sulphur is in excess. So 10 grams, we'll just work over here a little bit. 10 grams of iron divided by the MR of iron is 10 divided by 56. So 10 divided by 56 is equal to 0.179. So 0.179 moles of iron. And again, the ratio from there to the iron sulphide is 1 to 1. So if we have this number of moles of iron, we have exactly the same moles of iron sulphide. So mass equals moles, which is on the calculator screen here, multiplied by 88, which we've already worked out. So that gives me a mass of, for part B, 15.7 grams. So you would make 15.7 grams of iron sulphide from 10 grams of iron. Okay, so let's look at the second question here, where it says calculate the mass of iron that's needed to make 6 kilograms of iron sulphide this time. So firstly, this is our first introduction to kilograms, and this time we know how much of this is being made. We've got to work backwards and work out how much of this we need to start off with. The principle behind this question is exactly the same as before. Now, remember, your mass up here has got to be in grams, so my kilograms down here is obviously not in grams, it's in kilograms. So I can do 2 things. You can either take this value and multiply it by 1,000 and convert it into grams to give you 6,000 grams, and put 6,000 divided by 88, which would give me moles of this. Okay, or you can keep this just as 6, and then remember that your final answer over here will come out in kilograms. not in grams. So it's up to you. Either way is perfectly okay. You may well in an exam be confronted with tons as well, but it really doesn't matter as long as you remember if you use tons or kilograms up here on this side, your answer also comes out in tons or kilograms. Also, sometimes the examiner asks for the answer in a particular unit of grams or kilograms or tons. So make sure and be careful and read that. By the way, a ton is 1 times 10 to the 6 grams, or 1 million grams, for those of you who don't know that and where that may arise. So let's have a little look. Right, so we've got 6 kilograms of iron sulphide. So we do 6,000, okay, divided by 88. I've converted it into grams. Okay, it's really up to you. I don't really mind how you do it. So we've 6,000 divided by 88 gives me 68.2 moles of iron sulphide. We work back 1-to-1 ratio, so we will have the same number of moles of iron, and if we take mass equals moles times MR of iron, if you go to the periodic table, it's 56. So multiply that by 56 gives me 3,818 grams. Well, I'm going to put that just into kilograms because it's good practice to give your answer in the units that are given in the question. Okay, so again, you can pause the video and have a go at part B if you think you've got it correct. So that's 2A. 2B, then we have 1.6 grams of iron sulphide. Again, number of moles of iron sulphide is 1.6. So it's 1.6 divided by 88, which gives us the moles of iron sulphide as 0.0182. Please be careful not to drop decimal places. Again, a very common mistake that people do. Okay, again, the ratio is 1-to-1, obviously. So therefore, we multiply that by 56. Okay. And therefore, if I want to make 1.6 grams of iron sulphide, I need to start off with 1.02 grams of iron. Okay, and hopefully always judge your answer. Make sure it's a sensible answer, guys, because if I got 1.02 kilograms here, or some ridiculously high answer or ridiculously low answer, always question yourself and question whether that looks correct or not. Both those answers look pretty sensible, if you like. Okay. Okay, this time we're going to have a look at the industrial process, the Haber process, where we're using nitrogen N2 to react with 3 moles of hydrogen to make 2 moles of ammonia. Okay, so this is the general sort of reaction that allows ammonia, which is used to make fertilizers and explosives and a whole variety of things, oven cleaners and stuff, industrially. So let's have a look. The first thing again that we do, and we always do, is we work out the reacting ratios. So in other words, we have 1 mole of nitrogen requires 3 of hydrogen to give us 2 moles of ammonia. So let's look at question 1. Calculate the mass of hydrogen. So we're after the mass of this, required to make firstly 6 grams of ammonia. So again, remember, always jot it down. Okay, so we have 6 grams of ammonia, and we start off working out the number of moles that equates to for ammonia. Well, ammonia is 1 nitrogen, which is 14 plus 3. Okay, which makes 17. Again, please remember the MR is a mass of 1 mole only, so the 2 is not taken into account. The number of times that I see 6/34 for this question is, well, it's too often. Okay, so how many moles of ammonia are we going to have? Well, we're going to have 6 divided by 17, which gives us 0.353. 0.353 moles of ammonia. Now, we are looking to calculate out the mass of hydrogen, so to calculate out mass of anything, we need moles and MR. Well, MR of hydrogen is easy, it's two H's, so each H is 1, so it's the MR of that is 2, so it's going to be 2 multiplied by the number of moles. The number of moles of ammonia is 0.353, but remember it's 2 to 3 ratio, so the 3 is bigger than the 2, remember, so we've got to take that value and multiply it by 1.5 or divide it by 2 and multiply it by 3. I suspect it's the way that many of you might do it. Okay, either way, it's got to be 1.5 times bigger than this number of moles here, because the ratio is 2 to 3. So it's 2 multiplied by 0.529. Okay, which is 1.06 grams of hydrogen. That's for part A. Again, if you want to have a go at these without me doing them, just pause this and go do them. So let's look at B. Okay, now part B then, we are working in 2 tons of ammonia. So again, we can do what we did earlier, or what we didn't do earlier was this, and I'm going to do that this time, is we can just work in tons and then our answer will come out in tons. 2 tons, by the way, would be 2 million grams. We start working in bigger numbers and we want to try and avoid that and take the simplest route if we can. So 2 divided by 17, which is the MR of the ammonia. Mass divided by MR gives us moles, so 2 divided by 17 is 0.118. 0.118 moles of ammonia. Again, it's 2 to 3, remember. So we multiply that by 1.5 or divide by 2 times 3, gives us 0.176 moles of hydrogen, and we multiply that by 2 because the MR of hydrogen is 2, gives us 0.353. Now remember please that this mass value here, okay, this mass value here is in kilograms. It is not in grams. Again, this is a very quick is in tons. Okay, this is a very quick way to lose marks down here, getting the units wrong, as I have just demonstrated on purpose. Okay, so that's working backwards from ammonia, going back to our hydrogen. The last question I'm going to do here for you, okay, you can have a read of it there, is working forward. So we're looking to calculate the mass of ammonia made from, in the first one, 300 kilograms of nitrogen, 1 ton of hydrogen and 0.25 grams of nitrogen. So again, hopefully guys, you're able to crack on with these and do these really quite easily. So let's have a look. We'll do A first of all. So we're starting off with 200 kilograms of nitrogen. So again, I'll just divide this. Remember it's N2, so it's 14 times 2. Okay, so that's 200 divided by 28 is 7.14. So we have 7.14 moles of nitrogen. Remember we needed 1, 3 and 2. Okay, so again we will take that 7.14 and multiply it by 2 is 14.28. Okay, moles of ammonia, and we multiply that by the MR of ammonia, okay, which we already worked out at as being 17 previously, which gives us 242. 242, remember that is kilograms. B then, so we are 1 ton of hydrogen, so 1 over 2, which is the MR of hydrogen, I'm not using my calculator there, is 0.5. Remember now it's 3 to 2. Okay, so 0.5, you can either divide by 3 and times 2, okay, or multiply by 0.666, okay. So that gives us a number of moles there of 0.333 recurring. So we multiply that to get the mass times by 17, 5.67. Remember, we're in tons. Okay, C then, nice small little value now. So again, the moles of the nitrogen is calculated like so. So we have 0.125 divided by 28 gives us 4 times 4, 6 times 10 to the minus 3. Please be careful about your 10 to the minus 3s, etc. Loads of people will do this and then just completely forget about that and have 4.46. So their answer ends up being 1,000 times greater than it should be. So that is the number of moles of nitrogen. And remember from up here, what's 1 to 2. So we take that value on the calculator, multiply it by 2, gives us 8.93 times 10 to the minus 3, and that's moles of our ammonia. And we multiply that by 17. Okay, and that gives us 0.152. And this time it is in grams because up here we were working in grams. Okay guys, now there's lots and lots of past paper questions that you can have a go at if you trawl through the past paper questions or the past papers that are online and on the VLE, school VLE, you'll find lots and lots of moles questions. The mark schemes are also on the VLE, so you can check all of those. You can go back through this video and you can work on the ones that I have done to check that you understand them. Hopefully this clears up a lot of the problems that many of you have had with moles calculations, and this combined with your class notes should give you a fairly good blast at them. Okay guys, all the best. Okay guys, we're going to have a look now at some actual past paper questions on using balanced symbol equations for moles. Okay, so the first question, I'm going to go through the questions with you here. I want you to try and do them and then I will show you the answers. So if you can read the first one there, the question is about sodium hydrogen carbonate, which is used as baking soda in cooking, and the equation is as so. Then I ask you to calculate the RFM of sodium hydrogen carbonate, and then the question asks you down here, if you had 4.2 grams of sodium hydrogen carbonate was heated, calculate the mole of sodium hydrogen carbonate in 4.2 grams. You can just pause the video at each question and do it. And then it asks you to use the equation given above to calculate how many moles of sodium carbonate could be formed from 4.2 grams of sodium hydrogen carbonate up here. So there's the equation again. So again, pause the video and do the question, and I will click over to the answers now. So you should have realized first of all that the important ratio was as so, 2 to 1. The RFM of the sodium hydrogen carbonate was 84, of the sodium carbonate 106. The moles therefore of the sodium hydrogen carbonate was 4.2 divided by the 84 from up there, which give you 0.05 moles of the sodium hydrogen carbonate, and therefore you produced 0.025 moles of the sodium carbonate. Okay, again that was just taking into account the 2:1 ratio. Okay, now the next question, the final part of that question then asks you, based on the previous answer, calculate the maximum mass of sodium carbonate which could be formed from 4.2 grams of sodium hydrogen carbonate. Well, if we go back to the previous answer, that was 4.2 grams of sodium hydrogen carbonate was 0.05 moles. Give you 0.25 moles of sodium carbonate. Therefore, hopefully, we all just simply converted the moles of sodium carbonate into mass by multiplying it by the RFM, which you calculated in part 2. 2.65 grams is your answer. Okay, so have a look at the next one. So it says this question is about the amount of aluminium that can be prepared from a given mass of aluminium oxide. So first of all, what is the relative formula mass of aluminium oxide? Okay, it gives you our relative atomic masses there. So pause the video after each question or part of the question and do it, please. Okay, the next question then is, use your answer to calculate the number of moles of aluminium oxide in 1 ton. Note it is 1 ton this time. Okay, 1 ton of the aluminium oxide. Then it asks you to use the equation to calculate the maximum mass of aluminium metal could be obtained from 1 ton of aluminium oxide. So there's the equation. Okay, so essentially note the ratios and do the calculation. Pause the video again. So the answers are RFM of aluminium oxide 102. Moles of aluminium oxide then is 1 million, or 1 times 10 to the 6 divided by the 102 mass over RFM, which gives you about 9,803, 9,804. The moles is that. The ratio in the equation here is 2:1. Okay, so you had to multiply the moles up there by 2. Then you multiply that by the RFM of aluminium, which was 27. And you got 500,000 grams, or 0.529 tons. Okay, next question then. This relates to magnesium carbonate. So the question asks you, question is about the amount of magnesium chloride can be produced from a given mass of magnesium carbonate. So there's your magnesium carbonate. Okay, and it's asking you to react with hydrochloric acid to give you some magnesium chloride. What's the relative formula mass of magnesium carbonate? Again, pause the video after each one and do it. Relative formula mass of magnesium chloride. Use your answer to part 1 to calculate the moles of magnesium carbonate and 4.2 grams of the magnesium carbonate. And then use this equation, okay, to calculate the maximum mass of magnesium chloride that can be obtained from 4.2 grams of magnesium carbonate. Okay, so the answers are, part 1 is 84, part 2 95, part 3 0.05, sorry, it's just the 4.2 into the 80 divided by the 84, and the last one then, because it's a 1-to-1 ratio there between the magnesium carbonate and the magnesium chloride. Okay, you have the moles, which is 0.05, as calculated up there, multiplied by the RFM, which you calculated previously there, and the mass that you'd make was 4.75 grams. Okay, there's lots more of those examples if you go through the papers, guys, but those hopefully might help you.